everyone. My name is Mackenzie. I am a product manager here at Fermyon, and this is our December edition of Fermyon Cloud Office Hours. I have special guest Matt Butcher, our CEO, here to chat and code with us today. Matt, thank you so much for joining.
Yeah, thanks for having me on.
Of course. Well, it's the last session of 2023, so we got to do something exciting. I saw you chatting in our Discord about our Python SDK, so it sounds like you might have something related to Python to share with us today.
Yep. The little project I worked on after playing around with the advent of Spin, challenge number 1, that got me all excited, and so I built a thing, and now I'm going to show a thing and talk about a thing.
Okay. Did you do Advent of Spin Challenge 1 in Python then?
Yeah. I haven't written Python in a long time, and so here's a behind the scenes view of Fermyon. I didn't do anything to write any of the challenges this time around. So last year I knew all about the challenges going into it. This time I didn't. I find out about them when they go live on the site, and so I was watching a live stream when they did the big reveal. I thought, I'm going to go do challenge 1, and I'm going to try something I haven't done much of in a long time. So I've been writing so much code in TypeScript and in JavaScript and in Rust. I thought I'm going to go back and do some Python, which I haven't done. I went back and looked. The last time I wrote more than 3 lines of Python was in 2017. And that didn't really count in really any substantial amount. It had been like 2015. So I was way out of the loop. I missed the Python 3 transition, all of that kind of stuff. And I thought, okay, it's time to go play around with it. And that got me, I did the challenge. With the stuff I learned during the challenge got so interesting that I finished the challenge, submitted it, and went, I'm going to go write a thing and kind of play around with some of these other features inside of Spin, inside of Fermyon Cloud that I haven't gotten to use in Python yet. And so I wrote a little bookmarker tool.
Oh, cool. Well, I'm excited to explore that. Python holds a special place in my heart. It's the first language I learned in college, and playing around with Plotly and charting data sets that we were downloading. It brings me back. But that is a good segue. We have a few announcements we'd like to go through before getting into the demo for today. First, we'll go off the advent of Spin theme. It is now week 2, which means we're on to challenge 2 of the advent of Spin. If you aren't familiar, Advent of Spin is our annual coding challenge where every week we present a new task for you to solve. And hopefully along the way, you're learning a thing or two about Spin. And by the end of the series, you have a toolkit you can take into 2024 and build something pretty cool. It's week 2. It's not too late to join. If you are participating, love to hear it in chat. There's a link below. Last week, we built a wish list for Santa, aptly timed. And this week, we put in the wish list, and now we got to put in the work and come up with an algorithm to help Santa decide, what trip he should take, how much weight he can afford, how many kids he can visit. So it's good stuff. Visit the link down below to get started. And as we work on it, people are chatting in Discord, ask questions. Folks are more than happy to help. It is really a community-driven event.
One thing I noticed is that a lot of people are doing Advent of Spin 2022 as well, which is a completely different set of exercises and examples.
Yeah, that's a good point. If you want to maybe do a warm-up, see what's changed between the years, Advent of 2022 is up. You could be up to 8 weeks of challenges if you have some downtime.
Yeah.
We should have some special swag for that. Which is a reminder, there are prizes. So if you want to submit what you built by the end of the week, every Tuesday, there's a form that you can fill out really quickly. And we've built some pretty cool stuff to send your way. Also available on the GitHub repo if you want to take a look.
I think this week's is the puzzle. It's like the back cover of so this is Fippy's Field Guide to Wasm. We had a little map on the back cover, and I think am I right? This week is like the puzzle of that?
Yes, this week is the puzzle. So if you have some downtime in Christmas, I know that's a family tradition of ours, is dumping a puzzle box out on the dining room table. So this could be a fun thing to bring to the family get-togethers. All right. So that's it for Advent of Spin. A cloud-specific update. We mentioned this briefly last session, but the UI has been refreshed. So if you go to cloud.fermyon.com, take a look at some of your apps. We've dedicated a lot more space, real estate for you to explore what's going on there. You can view your metrics, your logs. Maybe we'll log in today with our Python demo and explore a little bit more. But yeah, some changes have been made. We'd love to hear your feedback. So in chat or on our GitHub repo, if you're hoping to see something new there, let us know because we're definitely eager to get that feedback. All right, and the last one is, believe it or not, we do have one more conference this year that we are going to. Actually, Matt and I will both be there next week. AI.dev down in San Jose, December 12th through 13th, I believe, if I'm getting those
Yep.
dates.
Yeah, that's right.
So we'll be down there, or if you're in the area, reach out. Yeah, really excited. It's the Linux Foundation event, and we'll be there to chat a little bit about Fermyon, about our serverless AI feature, and I believe you have a talk, don't you, Matt?
Yeah, I'm going to be talking about, I'm going to draw from my philosophy background and talk about LLMs. And I think the name of the talk is What It's Like to Be an LLM, sort of a play on a very famous philosophical essay called What It's Like to Be a Bat. So I'm looking forward to it. It'll be fun. I get to exercise my philosophy muscles for a change.
Woohoo! Get to learn a little bit about philosophy and AI all in one sitting. That's pretty cool.
Yep.
All right. That's it in terms of announcements from us about Fermyon Cloud. Thanks for everyone for listening to these sessions. And if you have any wish lists, perhaps for Fermyon Cloud, feel free to drop them in the chat of new features you'd like to see. Eager to hear what top of mind for you. All right. So should we dive into this Python app you've been working on?
Yeah, sure.
All right.
All right, I'm ready.
Started with Advent of Spin Challenge 1, and where did we land? What was the final product?
So I built a little bookmarking application, and I can put this up on the screen here. So a little bookmarking application, and we can see one bookmark here already. You add it, give it a title, you give it a URL, and then you submit it. Actually, let's grab one here and see. So I'm going to control this. By the way, the browser I'm using is Arc. I really am enjoying using Arc. It's a nice browser. So we copied this one. We're going to give it a title, Advent of Spin Hints. I'm going to give it I'm going to paste in the URL that I just copied, and I'm going to submit it. And this is going to take a moment. So now, well, it's not going to take a moment because it had a hard time reading the preview. But normally what we do here is, and we'll try another one because that was anticlimactic, developer.fermyon.com.
Oh, our developer docs website.
We'll do spin. Oops, let's try that in the right order. Okay, so that's our URL. We're going to call it dev docs. What is going on now? We might get to do some active debugging here in this session. Okay. But so what it should do is it'll take the title and the URL and it'll submit it up into Fermyon Cloud. Then Fermyon Cloud will fetch the URL. And I'm glad I saved this one right before we started. It'll fetch it and go out and grab the content of the page and feed it into Fermyon Serverless AI, the LLM, which is using the Llama 2 model. And it'll go parse out the HTML, grab the body of the text, send it to the LLM, get a summary, and then store the summary along with our bookmark so that we'll have a bookmarker that sort of summarizes things as we go, so that instead of my having to type in what the bookmark was pointing to, the LLM can kind of generate all of that for us. So that's the basic thing that we're building there. So we want to take a look. Yeah, go ahead.
So if our listeners are like me and maybe have 100 tabs open and 3 instances of their browser, this might be helpful.
Yeah, I think this is kind of an easy and fun way, or particular, like the way I was thinking about it at first, and there's still, this is the thing, my projects get going and then I kind of slowly iterate on them. But I was thinking what would be really fun would be to be able to create like an instance of this per kind of topic, so that I could create, a bookmarker instance for, holiday recipes and stuff like that, and then have this kind of like website where I could go and see by topic, that kind of thing. But yeah, it's sort of like a slightly advanced version of the kind of bookmarking tool you'd have in your browser.
Nice. And you've built all of this without having to purchase any GPUs, set up storage. It sounds like everything's already been wired up for you with Fermyon Cloud.
Yeah, I just used the Fermyon Cloud serverless AI stuff locally. When I was testing it locally, it actually took a little more setup to do it locally, and I'll give you a little peek about what I had to do that. But it was so slow testing it locally. Like fetching one page might take 10 minutes or so, because my GPU on my old MacBook is not strong enough to handle the kind of LLM inferencing. But with Fermyon Cloud, I deploy it in. I only have a free account at Fermyon Cloud. I never upgraded my account. So mine's on the free tier, and still I get like 2 seconds to generate the thing that was taking me 10 minutes to do locally. And it's, running it on the A100 GPUs that we have inside of Fermyon Cloud instead of my little Mac 1 metal GPU here.
Oh, that's pretty nifty. No installation required, and you're getting that performance right out of the gate. And to your point, it's available for anyone who signs up for Fermyon Cloud today in their free account.
Yeah, everything you'll see here is it's like free Fermyon Cloud account, where all I had to do was GitHub OAuth into it, and that was it.
Not bad. All right. So we saw then product. Where do we start from? If I'm a Python developer, how do I get started with Spin? And maybe why would I want to use Spin as a developer tool?
So so for me, the thing I really like about Python is that it's a very concise and easy for me to write language. It sort of formats the way my brain works. I just like it. But if I want to write just something that's going to be a very quick web application, I'm all about using any tools that'll help me get going faster. And that's what I liked about the way the Python API works. It's so easily handled that I think I install, other than having to install pipenv, I think pipenv was the only tool I installed other than Spin to get everything working. And the plugins and everything that are part of Spin made it easy to do. So I can, essentially, if I were to start a brand new, let me see where I am. If I were to start a brand new project, essentially I'd do Spin new. There you can see my last command was to create the bookmarker.
Okay, so this command here, for folks who may be new to the Spin CLI, we're requesting, it looks like a template, and it's a combination of the trigger type and the language that you're going to be using there, right?
Yeah, so there's the template I'm using, and I'm telling it I want to write an HTTP app in Python. So HTTP -py, and then I'm naming it Python Thinger. I know, very, very creative name, a thing in Python.
Better than test.
Yep. So then at that point, what I essentially have as the output of that spin new command. Actually, I'll do tree so you can see sort of everything in here. I've got a pip file, a readme, the app.py, and a spin.toml. And so, the pip file is where you store your dependency info. The readme is obviously the readme file. App.py is your Python code, and the spin.toml is the configuration file for Spin. And if I look at, app.py, I can see in there, okay, well, this is my code here. I'm importing a library. I'm writing a request handler. I'm returning a response, and that's it. I mean, effectively just a couple lines of code. And I can even, so I just created the generic template, right? But I can immediately compile it and have a version running. If I click on this, it's going to open up a little hello from the Python SDK, hello world thing, and we can see where that's coming from right there. So that's one of the things I really like about this, is to get a Python app up and running right away. Literally, that was 2 commands. And I'm off and running. And then from there, it's just a matter of like filling out the request handler to do the kinds of things that I want to do. And so like, I'm right into the business logic, right into building the thing I care about. There's no real scaffolding out of a framework or any of that. And then you had no starting a server no writing a server here, right? Spin abstracts away all the services and stuff like that. Even to the point where I could type in, spin deploy here, and have it go right out and deploy me an application onto Fermyon Cloud. So again, it's like all the boilerplate stuff that's so annoying to do is just handled for me.
Right, in a series of what we did, 4 commands maybe up and running. That is pretty amazing. For anyone tuning in right now, welcome to the December edition of Fermyon Cloud Office Hours. We have Matt Butcher, CEO here, walking us through how to build a Python application with Spin. End of the day, we're going to be able to bookmark some of our favorite websites and summarize what's going on within those, so we can return back and pick up right where we left off. And if you're tuning in right now, we are in the act of deploying the boilerplate application to Fermyon Cloud. Curious if you're tuning in, would love to hear what sort of programming language you're writing in. And if you're using the Spin SDK, that'd be great to hear as well. We'll be exploring Python today, but we also have support for JavaScript, Rust. There is also some TinyGo as well. I'll share the language guide for folks to take a look at.
All right, so perfect timing because we're all deployed now. And here you can see I'm actually hitting a public URL of, Python thinger random number or random string dot fermyon dot app. So I'm already, essentially that was a Spin new to create an app, a Spin build -- up to compile it and test it locally, and then a Spin deploy to push it out to somewhere public. And that was, it's just so nice to be able to do, have all that boilerplate handled so that I don't have to think about any of that stuff at all. I think from here, though, we can dive into the bookmarker app and kind of see. So we're going from like the couple lines of code to the bookmark app that we saw right at the beginning. That's the one that's generating this right here. But here's the app. So I'm using VS Code. I've got a couple different files open. I've got the app.py, which we just looked at as the code. I've got the spin.toml. That's the configuration file for Spin, and we'll talk a little bit about that one. Then I'm working on the index.html file, which is the UI that's displaying this right here. I went like totally old school on the HTML, so it's got like ye old form handlers, like zero JavaScript. It was like a flashback to 2005 for me. And then the pip file here is just where we set our dependencies. So so that's kind of the background on that.
Yep, got a nice lay of the land there. All right. So
what we saw. Go ahead.
No, I was curious. Like, give us a lay of the land of how you went about starting to build this app.
So when we looked at that example a moment ago in the terminal here, we could see the function that is created for us is handle request, and that's sort of a magic function, right? It's a request, as the name implies. It is a request handler. The expectation is that when a request comes in for my URL, it'll get the request object handed into this function, and my job is to return a response object back that tells Spin, how to handle things on behalf of the user. So when I looked at that, I got a request which I did nothing with because we were just using the boilerplate, and it returned a response which was, an HTTP response, a content type, and some bytes. So again, when I'm starting to build a bigger application, I start with that handle request function. Now, what I wanted to do was I wanted to say, can I write one Python thing that actually has one request handler, but has a router built in so that I can route things to multiple different endpoints on it instead of writing different Spin apps? So one thing I could have done here is I could have written, 4 different Spin Python apps, each of which implemented handle request once, and then have been and mounted each one to a different URI endpoint and been able to have the same kind of thing. But what I wanted to do is say, okay, I just want one Python app to handle a couple of different a couple of different routes. So what I did was,
sorry, quick question about that. Is that just purely a preference in design, or are there some advantages towards putting this all within one single application?
Oh, that's a great question, because it really gets down to kind of the coolest parts about being able to work in Spin. In a spin.toml, you can define a couple of different routes. So I've got a route here, and that's calling that bookmarker thing that we're looking at. But I also have a kind of commented out route here that points to a route called internal key value explorer, and that was using a different key value explorer front end. So you can even see, and I commented that out because I'm not using it anymore, but you can see how you could say, okay, I want to run a couple of different things on here, and I want to manage them as discrete different pieces of code. In this case, I used Radu's key value explorer. So I didn't write any code there. I just grabbed his WebAssembly module and was using that straight up. So if you're kind of putting together pieces of code to build more complicated applications, that kind of way of architecting things ends up working really well. Because, for example, you keep small code bases separate. So it's more like the microservice pattern. You can grab other people's code and just import it and expose it directly on an API, on a URI. And that's really nice. We've got a static file server that I use all the time, where anytime I want to serve a static file, I just add that to my spin.toml and I don't have to write a line of code to handle that. So there's some advantages there as far as like composing more complicated applications out of other pieces, other WebAssembly modules, other WebAssembly components, or another thing I could do is if I wanted to write part of the app in Rust and part in Go and part in Python, which is exactly the kind of thing I would do when I'm bored on a Friday. I could actually have one application and have a Rust code base, a Python code base, and a TypeScript code base all in the same project and build them into separate WebAssembly components and run them all. So some big advantages if you want to build things that way. If, on the other hand, and this was my goal here, if what I want to do is like just have one application where I'm working on just one piece of code and only sharing functions between different handlers here, it is so much easier to just write one application and compile it once to one WebAssembly component and just do things that way. So usually I find myself doing that when I'm writing like a specific piece of logic or a specific small little web app. The TypeScript JavaScript SDK for Spin has a little router built into it. And so I started using this pattern when I was writing JavaScript and TypeScript apps. And then I realized kind of after the fact, I like writing applications this way. It feels really natural and kind of similar to the way I used to write Go microservices. So I kind of began recreating that environment for myself in Python too.
Yeah. Thanks for walking us through that. And likely, if you're following along at home, either with this or Advent of Code, you'll probably be building one Spin application and following that pattern at least to start. And then maybe going from there and having many Spin applications interact with one another.
Yeah, I mean, it's probably not a bad idea to show how easy it is to add something else. So we saw there a commented out one, but if I wanted to add a file server, let's see, I'm going to do a Spin templates list because I can't remember. So in Spin templates, I can see there's static file server there. So I can literally do a Spin add static file server. What did I do wrong there? Oh, I should have done -t. So let's try that again.
Yes, this is great. And if you end up doing coding challenge 1 for Advent of Spin, you'll kind of learn this pattern of how to build an API, how to add static file server to render that content. It's just really a really powerful set of templates to get up and running with these style of applications where you just have that one pain point, and it'd be so nice if you automated or solved it. And we love building those kind of apps. We love seeing those on Discord. And here we go. We've added static file server to our app just like that.
Yep. And so that's, if you're using a static site generator, this is a super easy way to just serve those files out. Or if you're even just serving out an image or something like that, you don't have to hand code any of that. Just drop the static file server in there. Then you put actually we can see there in that config. Anything that gets put in the assets directory declared there gets served up here. So, if I had assets/foo, then my route would be static/foo would just access that static asset. So it's very, very easy and convenient way to map a bunch of static files to endpoints and be able to offer downloads or serve up images or static HTML or cascading style sheets or whatever.
Yes, we do have a few templates on SpinUp Hub, which is our home for all sorts of examples, plugins, triggers related to Spin. And I believe we have an SSG template for Zola. So if you have a static site generator you love, definitely recommend maybe playing around with that in static file server. And if you're feeling so inspired, uploading it to SpinUp Hub so others can maybe get started with that as well.
Yeah. All right, so we'll head back into our request handler here. So what I wanted to do was take any inbound request to the request handler, I wanted to say, okay, I want to use an in-code router to say, okay, if it's asking for slash or index HTML, go here. If it's asking for add, go here, and that kind of thing. So in the handle request method, I use this router and basically, pass all my information through the router and then handle whatever the router says is the correct target. So that router is actually this HTTP router project that's just a regular old Python project. You can go look on PyPy and see HTTP_router is a really well-documented project. It uses a similar routing format to something like Django. So if you've written Django apps in Python, it's like super easy to use. And it uses this neat annotation system that we'll see here in a second. So I just imported that library and started using it as it was. So outside of my handler, I declared my router object, and then inside of the handler, I used that router object and routed, the currently requested path through that router. And then the only really other thing I had to do with the router was on each of these methods, right? Each time I want to declare a route, I use this little annotation here and then write a method. So let's take a look at, I don't know, index is probably the easiest. No, actually, index is not the easiest one. Reset is the easiest one. So I added this annotation to a function that takes a request. And then in this one, I did just a little bit of logic, and then I returned a response. So very much like the example we looked at in the boilerplate auto-generated code. So request comes in for /reset. So here's the request. Comes into handle request, says /reset. I parse out the URL and pass it to the router, and the router says /reset is mapped, and we can see here on 69, to the function reset, and then it calls the function reset, and the response object gets returned all the way back to the user. That's all there is to the routing in here. I love the fact that this library is like super elegant. I just love the fact that I could find a library in a couple of minutes that did exactly what I wanted, and then just include it in my pip file and update my Python app and immediately have that available to me.
Yes, it's a great example of taking a library that's idiomatic to the programming language you're using, and we're going to do some magic behind the scenes with Spin compiled down to WebAssembly module. Like, you don't really have to worry about any of that process. You just get to use the libraries that you're familiar with.
Yeah. And Python is really cool. The way the build system works for that. So the caveat here is that you can use pretty much any library that uses any of the APIs that are supported by WebAssembly itself and Wasm. So currently, starting up network services and stuff like that won't be supported until early 2024. So you can't really use Python networking libraries, and you can't really use the Python threading libraries yet, because all of that stuff is still in flight, working its way through W3C, which is the standards body. But most of the other libraries in Python, I've been able to just use sort of out of the box. We can even see a couple others I used, an HTML parser. I used the URL lib parser. I used Jinja 2. So a bunch of like the kind of common libraries that you use in any old Python app just work. And that's been nice, but it's wild to go. It just works, and then consider for a moment what's happening behind the scenes. So when I run a build, right? So let's do one here. So I'll do a spin build, and we can see, it's running some tool called py2wasm, and it's outputting app.wasm, which we can kind of see over here in the left-hand navigation. But what's actually going on is it's loading a version of the Python interpreter, and then loading my libraries and my scripts all into memory, and then freezing those into a pre-instantiated WebAssembly module that has the interpreter and all my code kind of loaded up there in one binary. So, for all my code and all the dependencies get encapsulated in that one app.wasm. I think I should see how big it is.
Yeah, I'll take a look.
So let's see, there's my app.wasm. It's about 29 meg. And that's because I have pulled in the entire Python interpreter, the bunch of the core libraries, because I pulled in URL lib, which is a standard library. I pulled in JSON, which is a standard library. And then it's pulling in all the code for router, all the code in for the HTML parser, and all the code in for Jinja. Doesn't necessarily pull in much more than scaffolding for these spin libraries we use, because they're actually calling out through the WebAssembly system. So those are pretty lightweight. If you were to start with a language like, say, Rust, where it compiles down to very, very svelte little binaries, those binaries are probably 1 meg or under, I would imagine. And Go also fairly similar. It's got a very small runtime. But as soon as you're using an interpreted runtime, the amount of overhead you have to get, that tends to drive the sizes up a little bit. But again, 29 meg, is still a little bit smaller than if we were to just tar up an entire Python app and environment and deploy that somewhere. So, that gives you kind of an idea of the efficiency trade-offs you get here and how it works. But it is kind of cool that it just packages all that up, slurps it into one binary file. And that's not a tar file, that's actually a binary file that just gets executed by the WebAssembly interpreter. If we were to look at it, it's a bunch of bytecodes. So pretty cool. And the JavaScript TypeScript one works the same way, that you're kind of pre-initializing and freezing it in that pre-initialization state. It also means you can get some pretty good performance off of it, because when you think about the way an interpreter usually works, step 1, start the interpreter. Step 2, read in and parse the main application file. Step 3, pull in all of those other files, all the supporting files that are imported. And then step 4, you're executing, right? And when you build a WebAssembly binary, it pre-does steps 1 through 3. So as soon as you hit, your endpoint, like when we were, loading that web page, we were starting at step 4. We were just executing from there on out. So you gain some actual performance advantages with scripting environments when you're using something like Spin or one of these kinds of things that sort of preloads and pre-computes the initialization step.
And that is a beautiful explanation to one of the questions I had earlier, was how do we get languages like Python and TypeScript to work with Spin? So there you go. If you're curious about how we got that to work alongside some of the other languages that we have.
And there is a good example of a straight up interpreter compiled into WebAssembly. One of the people in our community created a Prolog Spin SDK, and it loads the interpreter in, and then real time, when you're executing something, loads the files into the interpreter, which works pretty well for Prolog. And so you can see examples of that method that's less sophisticated as far as how it works at build time, and more sophisticated as far as how it operates at runtime.
Yes, that was a very cool community contribution. I'll have to look on the side to see if I can find a link to reference. But yeah, that's a fantastic example that we saw someone go and just be excited about Spin and bring it to their language of choice.
I think there might be an example of it in Spin Up Hub, which is the great place to go if you're looking for examples of stuff.
Yes, it is. Take a look.
So while you're looking that up, so we're declaring, actually I'll collapse this. So we're declaring 3 different routes that we're adding to our HTTP router in here. We've got /add, which is going to be a post method. So this is where we're going to upload form content. We've got a route that handles both / the root and also index.html, the kind of default index page. And then we have that reset route, which is just my utility route for deleting the database when I want to delete the database and start all over again. So if we take a look at index, so this is the thing that is going to generate this page right here. So we can see this is going to be HTML. I'm going to have a form here. Somehow I'm going to list out all of this stuff. So how do we build something like that? So we start out by doing a couple of things. So we've got an HTML file somewhere. In fact, let's take a quick look at it. Here's our HTML file. You'll see if you look through it that it's templateized, right? We've got some Jinja template directives in here, and in particular, right here, we've got one. What we're doing there is I added a template logic in here to build this list of bookmarks as we go. So each time we render this page, and I'll just do a browser refresh here. Each time we render that page, you can see it so fast that you don't even see it. It doesn't even blink. But it's re-rendering this list dynamically each time I do it. And so I don't know. Let's try adding another one here, just because when we first started off, for those of you tuning in late, gave this a try earlier on, and something was wrong with my setup and it didn't work. But I redeployed it in the background while we were doing all this. So let's see if it works again.
Oh, nice.
So I did it again. So we enter the URL here.
We can add some error messaging for next time.
Yeah, I guess we should pull up the console, and we could see in the console on Fermyon Cloud whether or not we got any. So this time it's taking a while. So what's happening is I submitted spindocs as the title and developer.fermyon.com as the URL. It went out and it loaded up the parsed out the HTML and loaded that into the LLM, and the LLM came back and produced a summary for us, and that's all stored in the database. And so now we've got this. We just added a new bookmark, and this is stored in here. So if we refresh it, we'll see that kind of same thing every time. So that's background. That's what we're working on, right? So here's our template. There's this under the Your Bookmarks page here. It's going to create a list of things. And then other than that, this HTML is kind of like your classic HTML form. It's got a field for title here and a field for URL here. And that's about all there is to it.
So no cap on our list. It'll just keep growing as long as we keep adding URLs there.
Yep. The joys of writing all my code on a Saturday morning. It's YOLO code. Yeah. No cap.
That's okay. So, that's a good list to start with.
So here's my index function, right? So every time I hit / the root of my application, or every time I load index.html, here's what's going to happen. I'm going to set up a Jinja 2 environment. So this environment object comes out of the environment file system loader and select auto escape. These things all come out of the Jinja 2 library. So I'm going to set up my Jinja 2 library. I'm going to open key value storage, which is where I'm storing everything. I'm going to grab out of key value storage my bookmarks record. So this is all formatted in JSON. So I'm going to pull it out and then parse the JSON data. And now I'll have my list of bookmarks. If there aren't any bookmarks, I got an empty list of bookmarks. So if I were to go and reset everything now, it'd be empty. It'd be calling through this default path here. And then I'm going to use the Jinja template renderer. I'm going to load my index file, which is this one that we just looked at, render the template on this step, and pass in the list of bookmarks so that it knows what to render, and then send the whole thing back. So this is classic template rendering logic. This is the same kind of thing you do, in if you were to look at how Django does things or any of these kinds of systems, you'd see some variation of this particular pattern here. Get the template environment, load the data up that you want to pass to the template environment, and then render the whole thing, and then send the response back to the user.
And I see you've woven in a little bit of spin magic there. So if you're a Python developer, maybe new to the spin SDK, what are you doing in that open default line on 51?
So spin comes with built-in key value storage. So when you think of key value storage, you're thinking of a system like Redis or etcd or one of these environments where you have a key and a value, right? In this case, the key is bookmarks and the value is some JSON blob that describes my bookmarks. And so in key value storage, you have basically like 5 major verbs or something. It's get, which takes a key. It's set, which takes a key and a value. It's list keys. It's delete. And there's probably another 1 or 2 in there somewhere too. But just basic data persistence. So when you're writing a functions as a service kind of thing, like we are here, where the handler is going to start up and it's going to run to completion and it's going to shut down, we can't store state in the code request to request, right? Because the code is actually getting shut down and started up again. But if we do want to store state somewhere, key value storage is like it's easier than dealing with a file system, right? You're just getting and setting. And so that's what I'm using here. I open up a default key value storage, and I'm, in this case, just grabbing the bookmark record out. We can kind of sneak ahead and look at the add one here. If I look at add, I will see I'm opening key value storage, and I am creating my little bookmark object, and then I am setting it. So I'm setting bookmarks and then setting it to the encoded JSON. So you can kind of see we got really 2 big verbs there. We're getting bookmarks, we're setting bookmarks.
Which is super handy. You didn't have to worry about installing Redis or provisioning that store at all. We just need to know the verbs that we're calling and the data we want to pass and retrieve. And yeah, it's really handy to have that object to store data as we compile, make a mistake or two, change some things, and everything will be persisted locally. And the exact same SDK will work the same way on Fermyon Cloud, which is just fantastic.
Right, yeah. So when I'm doing it locally here, you can actually take a peek. Anytime you create a spin app, it creates a .spin directory, which is basically like all the local development data, and you can see in there's a key value database file sitting inside of there. But when I deploy it to Fermyon Cloud, it doesn't deploy this database file. It provisions me a brand new database in Fermyon Cloud. So my local test data here, when I do a spin deploy, it's not going to load my local test data into the production environment. I have different copies, and in fact, the version that's running in Fermyon Cloud is not a little kind of tiny single file database. It's stored in a big sort of high availability mode, backed by a completely different data source. So you kind of get the best of both worlds, right? You get the instant satisfaction of my not having to do anything at all to set up or manage local key value storage. And then when I deploy it, I get kind of the advantages of somebody else managing a high availability instance of this that I never even have to deal with it all, other than using this key value API to open, get, set, delete, that kind of thing.
Yep, exactly. All managed for you on Fermyon Cloud, and will be around as long as you choose to keep your spin application.
Yep. So we do this kind of template rendering pass, and then we return the response object really quickly, because I think we kind of glossed this before. In this case, 200 is the HTTP 200 response code. I'm telling it, yes, this is a successful return. If this is an error, I might change it to 500. If I wanted to suggest there wasn't a page here, basically I could set it to whatever codes I wanted. And if you've ever written HTTP apps before, these are well-documented HTTP standard codes, so you can look them up on anything from Wikipedia to the Mozilla docs, and you'll find the list. Then I set the content type here. Now I'm telling it that I'm sending back an HTML document, and that's so that the browser knows how to interpret the data that I sent back. And then I'm just sending back an array of bytes, which is basically just my rendered template. So very straightforward response that I'm returning back. No magic or anything there. It's just kind of your basic response. So that's what's happening when I go and I refresh this page, right? So what happens when I enter a title here and a URL here? So if we look at that HTML code, we'll see that the form action here says it's going to call add, and it's going to call add with the method post. So in HTTP, you've got get, post, put. You got to delete a couple of different methods. Post is the one you use when you're sending data up to something and you're expecting it to, go and create a new resource. So we're going to post some data. We're going to send it to the URL/add. So if we go up here, I'm going to collapse this again just so I don't have to scroll as much. There we see. Okay, there's add. And if a post method is sent to add, then it should run this function add URL. Once more, we have the request object. Let's see what happens here. So the first thing we're going to do is parse out the data that got submitted to the form. So and this is like in classic web development, right? When you do a post, it takes the values that are put in each of these fields. I should show this on the GUI. It takes the values that are put in each of these fields, and it lumps them into one big encoded string, and then uploads that encoded string. So the first thing we have to do is decode that string. So fortunately, Python has this parse query string method that decodes form data for us. So I decoded the form data into a dictionary, and then out of that dictionary, I grab title and I grab URL. Each of those is encoded. So I have to, or actually it's just an array of bytes. So I have to do a byte decode on that into a UTF-8 string. So essentially, if I were to dump the values here, right here, title is just a string title, URL is just a string version of the URL. So all that there is just kind of like your old HTTP mechanics there. If I were writing something more robust, I probably would just write that all into a function and be able to reuse that everywhere. But this is the only time I needed to do it.
Yep, and we're to our earlier point, we're trusting the user here to pass in the right input. So title is just simply based on what they would put in that form, and same with URL.
Yeah.
In the future, if we wanted to get more sophisticated, we could check for maybe, making sure that it's a valid URL and all of that fun stuff. But
yeah. So there's the name title and the name URL. So when it gets encoded, title is name equals and then the encoded string, and for this one, URL equals and then the encoded string. So that's exactly right. That's what we're decoding when we grab it out here.
Ooh, question about key value store too. What if I come back, I submit the same title, but I have a different URL?
So what I did in this case was I allowed people to create duplicates. So I didn't index on either title or URL. And I created a list instead. And I feel like I had a reason why I did that, but I don't remember what it was. Probably because I was testing the same URL over and over again. Probably the embarrassing fact of the matter is I designed this around my, how fast can I debug this?
Yeah, you're optimizing for the end user there.
I probably the rational thing to do would have been to key it by URL so that I didn't have duplicate URLs in my bookmarks file, so that I could have two things that were named important website, but if as the title, but if they pointed to different URLs, I'd just have two different ones. That's a good question. Now I'm embarrassed at my answer, but there you go. Design decisions made on the fly and how they result. So here,
it's still a very cool app. And who knows? Yeah, maybe you'll iron it out when you move on to storing recipes and you have 4 different spaghetti ideas. We'll get more sophisticated when that comes.
Yeah. I mean, and now I'm like sort of mentally re-architecting this, going, oh well, I could have made this an object instead of an array, and we'll see all that kind of here, that there are some easy design changes we can make and switch it over to that way. So I'm opening key value storage again in the add URL request. So in the other one we looked at, we were opening key value storage to get the list of bookmarks and display it. This time we're opening it so that we can get the list of bookmarks, modify it by adding our new bookmark, and then save it back out. So that's what we're doing here. So we open up that default key value storage again. And this time we're doing the same thing. We're getting the existing bookmarks or creating a new empty bookmark list if we don't have one. We're loading that and parsing that. So bookmarks here is going to be the Python representation of the bookmark object that was stored in JSON. So at this point right here, I've loaded all my old bookmarks and I've got the information for my new bookmark. I could just go straight on and store all of that, which is, I start to build up, append a new bookmark, serialize everything back to JSON and store it. But I added this little line here as my when I really got into this and when I want to do some AI stuff here, I added that particular line there. So we'll come back to that line in just a moment, but finish walking this one. So essentially I call summarize page and I give it the URL, and what I get back is a paragraph summary of the URL sitting on the other end. And then I take that information, title, URL, summary, create a new object based on that, add that to my bookmarks list with the append method, serialize all of that back to JSON, and store it back in the database. So this part, essentially from line 32 to 37 here, this is just the mechanics of adding a bookmark to a list and saving that new list.
And this list store.set, is that, what store are we interacting with? Is that still our key value store?
Yeah, so I open my key value storage, I name it store because I'm lazy and that's only like a couple letters to type. So load the bookmarks out of, and see, here's my key, right? So bookmarks is my key. Going to grab a list out of a value out of the key value storage called bookmarks. And then when I set it here, I'm going to reset it. Here's bookmarks and here's the new byte array. So essentially what I'm doing is reading it here and completely overwriting it right here.
Right, with updated value. And now key value store will remember that for us in between invocations as you go back and add more URLs in the future.
And Kenzie, to your point, actually, we could have done this piece a little bit differently, right? We could have said, in my key value storage, I'm going to create one record for every single bookmark. And then when I'm operating on the key value storage, all I'm doing is listing all the keys, all the different bookmarks, and grabbing and loading each object and then injecting those. And then when I add a new bookmark, I'm just adding one new key value pair to my database. We could have done it that way. I think what I had in mind when I did it this way was, I just want to store one list. I don't think this list is ever going to get beyond maybe 100 or 200 items. So serializing that to JSON and storing that as one record is fairly trivial. If I were storing multiple hundreds or thousands or tens of thousands of bookmarks, I would definitely want to take that other pattern and store each bookmark as a separate key value pair inside of the database.
Yeah, that makes a lot of sense from a design decision. If you're going to cap your bookmarks to something realistic where you're not going to come back and, have 1,000 to have to scroll through. Condensing it down into a single entry makes perfect sense there.
Yeah. And you're kind of making the trade-off between number of network calls. So in this case, only one to load one key value pair, and the amount of data that you're storing per value. And there's probably some tipping point where one makes more sense than the other, but this one was fairly simple.
And for those who are tuning in now, welcome to our December Fermyon Cloud office hours. We have Matt Butcher, Fermyon CEO here, and we are chatting about how to use key value stores with Fermyon Spin Python SDK with our bookmarking app, which we'll share out later at the end of this session. And so far, we've successfully pulled in a title, URL, some summary text. How the summary text appears, we haven't quite figured out yet. We might get to that and store it. All right.
And the last line of this function, we're returning a 303 redirect, and that's just redirecting back to index.html. So that's why when we went and added our bookmark, it refreshed back to this page. So no magic there. So I think we're down to the fun part, the LLM stuff.
Woohoo. All right. Yeah. I heard
So
summarize, and my mind immediately went, are we doing this manually, or did we maybe tap on Fermyon serverless AI for some help?
Yeah, I'm just like, this stuff is just so fun. So when we added these bookmarks, right, I added a title and I added a URL. Here's the title, and the URL is the link at the other end of this title. But this stuff here all got generated by an LLM. And then we saw I had a couple of failed attempts here right at the beginning and then got it working again. And so, we see again another summary here. So let's look at how that summary gets generated. So again, here we are, title, URL. Those are the two pieces of information I gave to the form. It calls this function called summarize page, and it hands it the URL. So if we go down to look at summarize page, it gets a URL, and then it goes out and fetches the response or the content from that URL. So I'm going to go, if it's example.com as the URL, then I'm going to create a new GET request, get example.com, and then get back a response object. I'm going to check it. If I need to follow any redirects, I follow any redirects. But most of the time, what I'm going to get back is a 200 response, 200 OK, and a gigantic HTML document. Okay, so this is the HTML raw code, with the nav bars and all of that kind of stuff in it. And I want to take that and get a summary out of that big giant HTML document. So what I'm going to do here is I'm going to first, here's the raw document that we got, the raw HTML document. I want to parse the HTML. So I used an HTML parser. There's a little bit of manual overriding I do here, but effectively what we're doing is we're trying to get the title attribute and the article, or the title tag and the article tag out of the HTML body. So the title will be, in the header at the top, and the article tag will be sort of the main body of the text on the page. So I'm just going to get that data out of the HTML. So I'm doing that with a plain old regular HTML parser. At the end of that, I'll have one piece of text that has the title and the article body. That's going to be potentially huge, right? So if I, this article here, what is it like to be an LLM, is, like 5 pages long. So I don't want that as my summary. I want to summarize that. And this is something that LLMs are very, very good at, is taking a body of text and summarizing it to your specifications. So what do? I write a prompt. And the prompt says a couple of things. It says inside of this sys tag here.
You've given it a persona to take on you.
There we go. I'm telling the LLM, you're going to act like this. You summarize text, you're concise and you're minimal. Give me a succinct summary of the article data that I pass you. And why I'm giving it this instructions is I want to tell it what kind of thing I'm after. And I'm queuing it into what bodies of text it should use as examples for what I want as output. And then inside of this inst tag here, I'm just dumping in the title and the content of the text. Now, the nice thing is I can trust the LLM to kind of figure out how to deal with the text once I've dropped that blob in. So I don't have to tell it any details about what the text looks like. It'll be able to tell what the title is and what the body is. And then I run this inferencing operation that says, hey, send all of this off into Fermyon Serverless AI, use the Llama 2 chat model, which is great for summarizing things, and then just give me back the text that I get back from the LLM. So running this summarize function, this part of it takes like the top part parsing takes like 4 nanoseconds, probably less than that. And then this part right here takes 3 to 5 seconds as it goes off to the LLM using these massive A100 GPUs and reads out all of that text and then summarizes it and sends me back something basic. So at the end of this operation, I've gone from a full HTML document to just one paragraph of plain text, and that's what gets stored in the summary field, and that's what ends up being this thing here or this thing down here.
And what's great about this is you don't really need to worry when you're going to be bookmarking your URLs, right? Because you're using Fermyon Serverless AI. So we have the GPUs up and running for you 24/7. You don't really need to do any sort of load forecasting on when you might or might not be using the app. You just get the flexibility of making that call and getting that summary on demand, which is just nice because I know from experience it does not take, or it takes quite a while to spin up a GPU powered VM. So this is super handy.
Yeah, and I think the GPUs have hundreds of cores on them, maybe not that many. They have a lot of cores on them. The ones that the A100s that are running in the cloud. My local one is woefully underpowered for any kind of work like that. I did test it locally, which meant I had to go get a copy of the Llama 2 chat model. I had to get a smaller one because I couldn't even work with the big one. So I got the 7 billion parameter model instead of the 13 billion parameter model, and did all the license agreement stuff, downloaded it locally, put it inside of this directory, and configured Spin to look there. So you can totally run it locally if you want. And in fact, if I were to run Spin up here, I'm not going to do this because we've got like 5 minutes left. And if I start this off, we won't even get to the end of the inference before the end of the live stream. If I were to start it up locally, I could run a local copy of this bookmarker. But for like the bookmark I just did before, it would be 5 to 10 minutes to do the inferencing necessary on my woefully underpowered MacBook compared to the seconds we saw when we ran it in cloud. Just because, and the only reason why is because GPU makes all the difference when you're working with an LLM. And when you can get one of these big, giant, beefy AI grade GPUs like an A100 or an H100, you can just plow through the number crunching that you need for LLMs. Whereas when you're doing it locally, we'd watch all of my CPUs spin up to 100% and everything would be very, very slow. In fact, it probably couldn't do it on the live stream because probably my video would get interrupted because of the amount of CPU power it uses up.
And would start whirling. Yeah, but that is a great call out. In the same way that you can use key value store locally with the exact same methods, you can use that LLM line down towards the bottom. You just need to do a little bit of prerequisite work, downloading the model, maybe making that trade-off of size and accuracy, but might be worth it to save your local machine. And we probably don't have time to explore it today, but if you are a Fermyon Cloud user, we do have a plugin that allows you to run your application locally with SpinUp, but actually call out to Fermyon Cloud and use Fermyon Cloud GPUs to make that inferencing request, which is kind of the best of both worlds. You can still do your local testing, but you might save your computer some hard work there.
Yeah, and that's just a Spin plugin. I think you just do like Spin plugin add remote LLM or something like that. I forget what the exact name of that is. And that would be a good thing if I were doing intensive development and I wanted to keep my inner loop development cycle going, but use somebody else's LLM and somebody else's GPU. That's a really good and easy way to do it.
Yes, I believe it's Spin Cloud -GPU. I'll also put up, that's not the plugin link, but this is the link to the source code that we've been playing with today. So if you are curious and you want to take it apart and learn a little bit by just running it yourself, that's a great place to go and visit.
All right, I think we made it through pretty much the code. And that was, this is a fun Saturday project for me. It was a lot of fun to get back into Python. And I, came out of it going, Python is such a fun language. I'm going to write more in Python now, especially after doing Rust, which is, you have to think so hard about Rust. And then in Python, it's like, oh, I can just type my thoughts straight into code and they execute.
You kind of get the instant gratification. It's fantastic. And that's what we're hoping will inspire others, especially as you work through Advent of Code. If you start to pick up these tools like KV and using serverless AI and maybe get inspired to build your own type of bookmarker. And maybe in the last minute, we can check the beautiful new Cloud UI dashboard. Look at that. We can see we've been generating some traffic on this app so far today. And a little overview.
If we were to look in here, we would see, I got a couple of errors here and there because I don't have a favicon set up, a little bit of, so when I'm debugging on the cloud, usually I would use something like this quite a bit more. But yeah, this is, I really like this upgraded cloud thing too. I can see more at one glance than I used to be able to. So I love that.
Yeah. And this page right here, the activity page, when you land on it, this is the past 24-hour snapshot of your app. So we can see the last time it was deployed, the logs within that window, metrics. And then if you want more of a history, drilling down on that left sidebar will give you logs from, an extended period of time, metrics, change your custom domain, all of that good stuff. All right. Well,
hey, this
Matt,
is cool.
Thank you so
Sorry, I'm sidetracked by the.
If you add a custom domain, it'll show you in the events tab. It's a lot of fun. But thank you so much, Matt, for stopping by and helping us wrap up the 2023 Cloud Office Hours. We'll be back in January for the next session. Hope to see you on Advent of Code. And just have a fantastic rest of the year.
Yep.
Bye, everyone.
Thanks a lot. This was fun, everybody.